Okay. Good evening. I'm Mary Augusta Thomas, the Deputy Director of the Smithsonian Libraries, and it's my pleasure to welcome you here this evening. It's a delight to see so many people here. At the heart of every Smithsonian museum and research center is a library. There are 20 of these libraries, including one in the Republic of Panama. Individually, each is among the great repositories of knowledge, but collectively, we believe they are one of America's most precious scientific and cultural treasures. Now, with one exception, none of the libraries is on an exhibit floor or sitting prominently past some display case, or for that matter, even identified by a well-placed sign. Instead, they're tucked away, off to the side, out of the way, but working hard every day. That's why we're so happy when we can share a portion of our collections and our expertise through exhibitions and lectures like this evening. Our library collections are truly amazing. We have over 2 million books, manuscripts, maps, prints, paintings, research data, and physical artifacts. Anything and everything you could possibly imagine in a library. The subjects, likewise, are all-encompassing, including aerospace to zoology and much, much more. And you are able to visit all of them to do your own research at any time. In addition to coming into our libraries, the internet provides constant access to our collections. Last year, there were more than 1 million web visitors and nearly 9 million web content downloads. That's a lot of use. So I want to thank all of you who are supporting us. You're attending our events, you're visiting exhibitions, you're using our libraries, and through your taxes and your generous private donations, you also help us continue. You ensure that all of that information remains readily available to researchers, scholars, and visitors from here and around the world. We're pleased to be able to offer this evening's presentation, our 21st Dibner Library Lecture. Let me give you a brief background. For those of you who don't know, Bern Dibner donated his rare book collection, a generous portion of it, to the Smithsonian in 1976. The Dibner Library of the History of Science and Technology, as it's called, is located, in fact, on this floor of this museum, but right now is behind the construction barriers. However, the library is open for use, and some of you I know have been in using it. Bern was an electrical engineer who patented a device in the 1920s, which allowed him then to pursue studies. He became fascinated by Leonardo. That led him into the history of science, and from there, the sky was the limit. History of science collecting was really his passion, and from anything you can see about our collections, you can tell he followed his passion. He bought, he gathered, he swapped, he learned more about books for probably the next 60 years of his life. And one of the things he wanted to do was give back to a nation he felt had enabled him to do this. So he made the offer to the Smithsonian, and in 1976, the collection was relocated here. A greater portion of it. There is also Dibner material in several other places, but we are the Dibner Library with the primary collections. So now it's my pleasure to introduce Lila Veckerdy, our head of special collections and our Dibner librarian, who will tell you about the rest of this evening's program.
Thank you, Mary Augusta, for this very nice introduction. And I will follow with another introduction. I would like to introduce to you our tonight's speaker, Lawrence M. Principe. Lawrence M. Principe is professor at Johns Hopkins University, both in the Department of History of Science and Technology and the Department of Chemistry. Holding joint appointments in these two departments, he is the inaugural Drew Professor of the Humanities. In addition to his Hopkins PhD in the History of Science and Technology, Dr. Principe also holds a doctoral in organic chemistry from Indiana University. So in the German educational academic system, in front of his name, there would be 3 abbreviations, Prof, DR, for Professor Dr. Principe. Dr. Principe's scholarship concerns the early history of chemistry, including alchemy and its relationship to modern chemistry. He has worked to reveal the substantial scientific contributions of the alchemists, their laboratory methods, their theoretical frameworks, and the key roles they played in the emergence of modern-day science. His early works focused particularly on Robert Boyle. In his book, The Aspiring Adept, Robert Boyle and His Alchemical Quest, 1998, Dr. Principe makes the case that Boyle was himself active as an alchemist. His later book with William R. Newman, Alchemy Tried in the Fire, Starkey, Boyle, and the Fate of Helmontian Chemistry, 2002, also promotes the continuity between alchemy and chemistry and was awarded the Pfizer Prize by the History of Science Society in 2005. His most recent book, The Secrets of Alchemy, published in 2013, provides a survey of the history of alchemy and includes explanations and replications of alchemical processes. So if you want to learn how to do it, that's the book to go to. Professor Principe's interest in alchemy goes back to when, in a public library, as a high school student, he was looking for reliable books on the subject to generally get familiar with it. I think that quest was unsuccessful at that time. It is great that now such a book, The Secrets of Alchemy, written by him, is available for anyone who is interested in reading a comprehensive work on alchemy. Professor Principe has been recognized extensively for his excellent scholarship as well as for his creative teaching. In 1999, the Carnegie Foundation chose him as the Maryland Professor of the Year, and in 1998 he received the Templeton Foundation's Award for courses dealing with science and religion. Johns Hopkins has repeatedly recognized his outstanding achievements through numerous awards, the Distinguished Faculty Award, the Excellence in Teaching Award, and the George Owen Prize. In 2004, Dr. Principe was awarded the first Francis Bacon Prize by the California Institute of Technology, granted to an exceptional scholar whose work has had substantial impact on the history of science, the history of technology, or historically engaged philosophy of science. Tonight, he will deliver his lecture titled Alchemy on the Cutting Edge, Theoretical Innovations and the Pursuits of Transmutation. Professor Dr. Principe.
Good evening, and thank you for that very kind introduction. I'm very honored to be here to address you, and thank you all for coming out. It's a wonderful turnout, and I appreciate that very much. I remember as a younger scholar reading one of the Dibner lectures that was given on alchemy by Betty Jo Teeter Dobbs some years ago, and that was a very important publication, and so I'm especially delighted and honored to be able to add to that series of publications. Well, this evening, I'm going to depart from my usual study of alchemy, which generally deals with the early modern period, the Middle Ages, and instead to talk about something that is actually new for me, what happens to alchemy afterwards, after its great heyday, and I found a number of surprising things that I'd like to share with you tonight. So when I was casting about for catchy titles for this lecture, one that came to mind, rather than the one that I decided finally on using, was Alchemy and Chemistry, Breaking Up and Making Up, Again and Again. And so what I'm going to talk about this evening is the strange little minuet that alchemy and chemistry have danced with one another over the past 300 years. A little recognized on-again, off-again romance that followed a far better publicized stormy breakup. So to do this properly, I first have to say a little bit about alchemy, a topic that's generally a bit less well known than chemistry is today, although I'm doing what I can to change that. Until quite recently, history, or actually to say it more correctly, the people who write history, have not been terribly kind to alchemy. The prevailing image was that of an archaic, perhaps superstitious, perhaps simply fraudulent, and at best, senseless pursuit of making gold that contributed little to human knowledge. Historical figures such as Robert Boyle were praised specifically for their clear-sighted rejection of alchemy and their introduction of scientific methods of experimentation and observation that laid the foundations for what we know as modern science. Now, some more modern, and when I say more modern, what I mean is 19th century, reinterpretations of alchemy treated it more positively, but only by seeing it as an esoteric or occult wisdom or spiritual endeavor, which thereby again emphasized its distinctness from chemistry. Now, efforts over the past generation have greatly modified these views. Alchemy is now recognized as a key part of the history of science, and many alchemists, centuries before the emergence of a modern chemistry, developed a sophisticated experimental techniques and based their work and ideas on logical theories of matter and its transformation that they derived from observation and experience. In fact, I would argue alchemy, perhaps more than any other scientific practice, instilled in early modern Europe a culture of practical experimentation and observation as the means of exploring nature. Figures like Boyle did not reject traditional alchemy, but instead they learned from it, often continuing long-standing aims such as the search for the philosopher's stone and the transmutation of base metals into gold. Alchemy has now been revealed as something largely indistinguishable from chemistry in the early modern period. And indeed, the two words, alchemy and chemistry, were used largely interchangeably until somewhere around 1700. Well, for this reason, my colleague Bill Newman and I, some years ago, proposed that scholars use the word chemistry, that's C-H-Y, two Y's, chemistry, to refer to the undifferentiated pre-modern whole, thereby avoiding the modern connotations of the words alchemy and chemistry. And if you want to think about that for just a second, what ideas you connect with alchemy and chemistry? Alchemy in the title was probably a better draw for this lecture than had I used chemistry on the cutting edge, just as a guess, right? It's unfortunate as a chemist, I feel, but nevertheless. So the word chemistry with a Y, correctly signifies the original synonymity of alchemy and chemistry. But as much as I, as an early modernist, would like to forget the emergence of a post-17th century world, I must confess that I can't actually ignore the fact that the two words now have distinct meanings. Alchemy has since then, since about 1700, generally signified a pre-scientific practice aimed predominantly at making gold. So my first question is, where, when, how, why did this come to be? Well, there's a ready answer. At some time around 1700, increasing scientific knowledge ruled out the possibility of transmutation. Well, like most ready answers, this one is wrong. In the first place, it reads history backwards from our current state of knowledge, and in the second, it's based upon the fallacy that transmutation had either no or only weak theoretical foundations, and thus was easy to refute. But in fact, transmutation was the logical consequence of a coherent theory of matter. In particular, that the metals are not elements as we think of them, but rather compounds, made up of the same 2 or 3 ingredients combined in different proportions or purities. Therefore, changing one metal into another was, in principle, an easy matter of changing the proportions of their common ingredients. Okay, so very logical. Besides, such transformations appeared to happen naturally underground, as was witnessed by the common observation that most lead ores contain some silver, most silver ores contain some gold, as if the metals were naturally progressing, transmuting one into another underground. So the quest for metallic transmutation was a reasonable pursuit based on the best knowledge then available. So why then did transmutation disappear from the customary interests of chemists? Sometime in the early 18th century, at the same time the word alchemy began to refer exclusively to transmutation. Unfortunately, I don't have a complete answer for you this evening. The disappearance of transmutation happened in different places at different times, for example. And so I'm going to restrict myself this evening predominantly to one locale, France, and an examination of its official scientific body, the Académie Royale des Sciences. And here, in what is arguably the most important locus for the development of chemistry during the 18th and 19th century, surprising developments can be made. Between 1665, just before the founding of the Academy, and 1700, on at least 3 occasions, the study of metallic transmutation was forbidden to the Academy's chemists. Now, strikingly, all of these restrictions came not from scientists, but from political figures and administrators. First from Louis XIV's minister Jean-Baptiste Colbert in 1666, then from Colbert's successor Louvois in 1685, and finally from the king himself in the early 1690s. Why? Well, interestingly, in one case, a reason is given, namely that the king, and I quote, did not want his enemies to think that his power came from gold making. So what you see, it's a completely political and economic motivation, not a scientific one. Now, the Academy's chemists, and I'm going to put 2 of them up here now, the Academy's chemists acted the way all academics should towards administrators. They ignored them. The 3 most prominent chemists of the Academy's first 50 years, Samuel Cottereau-Duclos, Wilhelm Homberg, who unfortunately I don't have a picture of, none survive, and Étienne François Geoffroy, all worked openly and unapologetically on transmutation. No evidence-based refutation of transmutation ever appeared at the Academy. But when the administrative decrees were replaced with rhetoric insisting on the purely fraudulent and inherently deceptive nature of all claims of transmutation, that's when transmutation finally disappeared from the Academy in the 1720s. And this rhetoric was crafted primarily by the Academy's secretary, not a chemist, their PR man, so to speak, Bernard de Fontenelle. Geoffroy, there he is, did in fact finally assist in this endeavor in 1722 by giving a public description of the supposed frauds practiced by those claiming successful transmutation. For example, having gold hidden in a false bottom of a crucible made to appear at the right moment. But he never said that transmutation was inherently impossible. In short, it was the linking of transmutation with socially unacceptable behavior that made transmutation vanish, not scientific argument or evidence. Thus, alchemy, gold making now, and chemistry, a modern science, seem to have parted company definitively in France in the 1720s in a very unfriendly divorce. Now, over the past decade, I've been rummaging through French archives, which is great fun, and I've turned up many previously unknown papers by the Academy's chemists, and these papers tell a very different story. The pursuit of alchemical transmutation did not die out, it merely went underground. Geoffroy, as it turns out, continued his interest in transmutation well after his 1722 paper, until his death in 1731. More amazingly, virtually every Academy chemist, I'm going to say that again, virtually every Academy chemist thereafter also pursued or defended transmutation until the 1770s. Now, significantly for our understanding of alchemy, I should say they pursued it, but they generally kept quiet about it. Significantly for our understanding of alchemy, these 18th century chemists did not cling to outdated ideas and explanations in a kind of scientific contrarianism. Instead, they brought the newest chemical ideas and discoveries, many of which they helped to develop, to bear on the problem. Far from stamping out the pursuit of transmutation, virtually every new chemical theory and discovery perpetuated it. Now, I'm going to change the slide in just a second, but I noticed when I was going through this that besides giving you a sort of gallery of chemists, it's also very interesting to watch their hairstyles change down to the 20th century. So if the chemistry bores you, you can keep an eye on hairstyles. So take, for example, Guillaume François Rouelle. When he described a 17th century preparation for a special mercury needed to make the philosopher's stone, he didn't repeat 17th century explanations of how it worked. Instead, he referred to phlogiston, the centerpiece of contemporaneous chemical theory. He also kept a secret laboratory in Paris where he worked exclusively on transmutation. And he told his students in the 1760s, of whom Lavoisier was one, that, quote, "The generality of natural philosophers doubt the truth of alchemy, but they are not able to be judges of a subject that is entirely unknown to them. The most knowledgeable chemists do not call it into doubt." He's saying this in 1765. In regard to the philosopher's stone's ability to turn base metals into gold, Rouelle asserted, and I quote again, "The most sensible and knowledgeable chemists have believed it. The ignorant ones and uneducated people are the ones who have denied it." Likewise, when the mathematician Pierre-Louis Maupertuis wrote sarcastically about the stone and transmutation, the chemist Pierre Macquer penned an unpublished refutation that not only drew upon contemporaneous chemical theory to defend it, but also used that theory to suggest new avenues of practical experimentation to achieve it. Success, he wrote, quote, "resolve one of the most beautiful and most difficult problems in natural philosophy." Thus, alchemy, in the now narrower sense of metallic transmutation, persisted in the Academy, the highest echelon of the French scientific establishment, far longer than anyone previously imagined. Alchemy, rather than being weakly founded and ready to be toppled by scientific scrutiny, proved flexible and dynamic enough to incorporate the newest chemical theories and endeavored to benefit from them. It's only around 1780 that such continuing interest and belief seems to have come to an end. That should be considered a conjecture at this point. I haven't looked well enough at that period. Possibly, again a conjecture, this is due to Lavoisier, who made much of the immutability of the substances he listed as elements, including the metals. Dalton's atomic theory from the first years of the 19th century, based on immutable atoms, probably also contributed to a suppression of alchemical hopes and practices. So then, did this period mark the definitive divorce between alchemy and chemistry? Well, from the vantage point of about 1800, it might have seemed so. At present, I'm not aware of any significant French chemists who pursued transmutation at that time, but I'm waiting to be corrected on that. Yet transmutation had already proven its resilience, and this apparent parting of the ways was only temporary, for in the mid-19th century, alchemy and chemistry flirted with reunion again. And this brings me to a major part of my story this evening. In 1819, in a small village just outside of La Rochelle on the Atlantic coast of France, was born one Cyprien Théodore Tifro, later to be called the alchemist of the 19th century. Trained as a chemist, by 1840 he was the chemical demonstrator of the École Professionnelle of Nantes. In December 1842, he left France for Mexico, where he supported himself using a new invention, daguerreotyping, an early form of photography. The daguerreotypes he produced are now unfortunately lost, but when they were later exhibited in Paris, they were highly praised for their technical innovation and their composition. In fact, one of the reviews I read of it marveled at the fact that he took a photo of a Mexican marketplace where the figures who were moving were not blurred. So somehow he had figured out a way to make the daguerreotyping medium more sensitive to light. Tifro later recounted that he went to Mexico because he had become interested in metals and wanted to study precious metal ores and mining, using photography as a cover for his real purposes. In Mexico, he conducted numerous experiments and, in 1847, achieved a result that would inspire or haunt him for the rest of his days. After exposing nitric acid to the rays of the sun for several days, he poured it over filings of a silver-copper alloy and left the mixture in the sun. Some of the filings dissolved, but not all. He then boiled the mixture and added more acid. Upon repetitions of the process, the initially greenish-black residue grew lighter and lighter in color and finally turned a brilliant metallic yellow. His tests, and those that were done later by others, showed that it was now pure gold. He closed up his Mexican daguerreotyping business and returned to France in May of 1848. At the end of 1850, he sent a paquet cacheté, that is, a sealed packet, to the French Academy of Sciences. Such packets, these were used by scientists and inventors to claim priority for a discovery before they were ready to go public with it. So these paquets would sit in the Academy's archives unopened until the depositor said, well, open it and read it, or send it back to me, I made a mistake. Tifro sent a second packet in May of 1852, which he later revealed, when it was opened by the Academy on his instructions, contained a sample of his transmuted gold. Now, one thing I haven't done is I did check with the Academy of Sciences, and all the paquets cachetés are inventoried and remain there in the archives. So I'm very eager to go and see if Tifro's sample is still there. Technically, it should be. The big event only occurred in June of 1853 when he decided to announce that the gold was made by transmutation. He had an 8-page pamphlet printed up and sent a copy to the Academy and asked for their opinion. Now it's interesting, here this man is doing transmutation in the middle of the 19th century. What does he do? He sends it to the Academy of Sciences in Paris. We'll find out why in a moment. Now, unfortunately, Tifro ran afoul of the Academy's strict policy of never commenting on anything that's already been published. Well, in fact, there wasn't much to comment on because Tifro gave no details about how he carried out the transmutation, only that he'd done it. But a truly remarkable thing happened next. The Academy invited him to address them in one of their normally closed meetings. So on the 17th of October in 1853, Tifro read to the official scientific body of France a new paper on the transmutation of silver into gold. The Academy's reaction was to put together a commission of the 3 most respected chemists in France to study his results seriously. Who were they? They were first Louis-Jacques Thénard, second Michel Eugène Chevreul. You'll notice he lived to a wonderful old age of 103, and I couldn't resist showing you a picture of him at 102, because he looks like he would have been a great professor, right? Doesn't he look like he would have been fun? And the third, the youngest, Jean-Baptiste Dumas. Now, this response really should shock us. At virtually any early period of the Academy, Tifro would never have gotten a foot in the door of the Academy of Sciences, much less an invitation to address them directly. What had changed? Well, one thing that had certainly changed was chemistry itself. In the mid-19th century, the notion of immutable elements had been shaken by several recent discoveries. The first followed upon the measurement of atomic weights, that is, the relative weights of the atom of one element relative to another. A remarkable thing had been observed. The atomic weights of nearly every known element, about 50 at that point, were integral multiples of the weight of the lightest element, that is hydrogen. Carbon, by their measurement, weighed exactly 6 hydrogens, oxygen 8, sulfur 16. There was no reason to expect such a strange and striking regularity. It was as if you had gone outside and randomly picked up 50 rocks, brought them in, weighed them, and all of them weighed an even number of grams. What's the probability of that? Well, this strange outcome led William Prout in 1817 to propose that all the known elements were actually condensations of hydrogen, and that hydrogen was the unique building block of everything. Chemists very soon lined up on opposite sides of the issue. Just a moment. I think we've got that in the wrong order. Right, let me skip that one for a moment. There's Prout. Berzelius denied the possibility and spent years refining the measurement of atomic weights, showing that some elements, you could only bring up 2 of them actually, copper and chlorine, did not fit the hypothesis. And of equal stature on the other side was none other than Jean-Baptiste Dumas, the youngest member of Tifro's commission. He had been remeasuring atomic weights to confirm Prout's hypothesis. Dumas also played a key role in the exploration of a second discovery, that of isomerism, namely that some organic compounds were composed of the same atoms in the same number, yet showed very different properties, meaning that there must be some unsuspected internal structure that determined the properties, rather than just the kinds and the numbers of atoms they contained. Finally, Dumas also worked on what was called radical theory. Chemists had noted that some clusters of atoms, some groups within molecules, generally survived intact through multiple reactions, as if they were especially tightly joined to one another. One such cluster or radical was ammonium, which had been shown to contain 1 nitrogen and 4 hydrogen atoms. Yet ammonium not only transferred without breaking up from one compound to another, and could easily take the place of a metal in metal salts. In other words, implying that it itself was actually metallic, a metal that was composed of non-metallic ingredients. So there were ongoing attempts in mid-century, some that seemed to promise success, to isolate ammonium as a new and a compound metal. So as you can imagine, these ideas breathed new life into the old question of transmutation. If Prout was right, adding or subtracting hydrogens could interconvert all the substances thought to be elemental. Radical theory implied that metals could be compounds after all, just we hadn't found the right way of breaking them up yet. And isomerism meant that metals could be composed of the same very few ingredients, but still have very different properties. Strikingly, chemistry here returned in 1850 to a view of the metals as compound bodies, not really very different from that of medieval alchemy. And this resemblance was acknowledged by chemists then. Dumas noted that these questions, I quote, touch upon the issue of the transmutation of metals. Answered affirmatively, they would give chances of success to the search for the philosopher's stone. Alexandre Baudremont, after discussing the issues in his 1846 chemistry textbook, predicted that, quote, the alchemical dream of metallic transmutation may in fact be soon realized. So given the interest in these questions, in 1853, when the Academy received a memoir entitled "The Metals Are Compound Bodies," and claimed success in transforming one metal into another, that was, I think, sure to provoke interest, regardless of the clear connection to an officially discredited alchemy. Now, while Tifferot explicitly linked his experiments to earlier alchemists, he never resorted to their explanatory theories about metals, but instead, like Rouelle and Macquer before him, appealed instead to the latest chemical ideas. He refers to isomerism and polymorphism very much as Dumas did in his chemistry lectures, and to, quote, "the unknown radical that constitutes the metals. Everything," he says, "leads me to believe that this radical is hydrogen, a clear link to Prout's hypothesis. This radical," he suggests, "is modified by the amount of oxygen bound to it, a process linked to nitrogen as a catalyst or ferment. The more oxygen," Tifferot suggests, "the more inert and the denser the metal becomes. Hence, the conversion of copper to silver to gold involves the sequential addition of oxygen to the metal radical via nitric acid that he had used, a known oxidizer." Obviously, these are all terms and ideas that the earlier alchemists had never heard of. So, how did the Academy respond to Tifferot? 3 weeks later, on the 7th of November, 1853, the Commission declined to take a position. Why? Because Tifferot gave them only results and still no experimental details. So, our alchemist asked for another audience, but he was told, "just send us some details," which he did, but not before taking a really remarkable step, and I was astonished to find this when I went looking for it. Now I have to go back to the slide He applied for and received a brevet d'invention, which is akin to a patent. And if you look there, second from the bottom, number 191, you can see le brevet d'invention de 15 ans, a patent basically for 15 years to Tifferot for the transmutation of metals one into another. So he actually goes and gets a patent on this before he'll reveal more to the Academy, which I think is clear evidence that he wasn't just some kind of joker. He really believed he was going to put this into manufacture. His third memoir, presented in May 1854, does describe his experiments, but also answers a question you probably have in mind by this point. If this guy can go and make gold, why is he talking to the Academy at all? Why doesn't he just go and do it? Okay. Well, the memoir reports that although the process worked 3 times in Mexico, it has since failed to work efficiently back in France. And this is why he appeals to the Academy's chemists, he even asked for some physicists to be involved too, to help him figure out what's going wrong in France. He suspects the missing factor is the intense sunlight of Mexico, and he spends a lot of time trying to add heat and electricity and magnetic fields to make up for what's missing in France, which doesn't work. He apparently experimented a great deal with the chemical effects of light while he was in Mexico, and this focus on light probably links to his daguerreotyping. He also sent the Academy a paper on the action of sunlight on a mixture of nitric acid and carbon disulfide in a sealed tube, and the Academy deemed it worthy of publication, which they did. They published it in their journal, and it was thereafter translated into German and reprinted in the Journal für praktische Chemie. So Tifferot is actually doing some chemistry here that seems to be worthy to get published. He sends 3 more papers about transmutation with further details in each one, and even had a related process examined, with ambiguous results, by the assayer of the Royal Mint. Imperial Mint in 1854. But while he waited in vain for an official response from the Academy, he did wait in vain. They never actually replied to him. Losing patience, he took his case to the public, printing up his 6 memoirs. There they are. his 6 memoirs into a slim volume in 1855 and asking the Academy again for their assistance, which now, because he published it, they can't actually give. After sending 2 more memoirs, Tifro fell silent in 1858. I should mention that there is, as far as I can tell, only 2 surviving copies of a German translation of this work published in Berlin. So who did the translation and who was responsible for the publish, I don't know. You'll notice also in the French title that there's a clear link to The Alchemists because he co-published this with a member of the Academy of Moral and Political Sciences, Franck, who spoke on Paracelsus and alchemy in the traditional sense. So Tifro himself is making the connection with traditional alchemy, not just doing it as chemistry. Was Tifro's engagement with the Academy fruitless? Well, he was disappointed, but there may have been a less visible response. In 1857, Dumas presented a lengthy memoir on the problem of the elements, revisiting and revising Prote's hypothesis, and stating more strongly his conviction that the metals are actually compounds. This memoir was attacked by a fellow academician, the physicist César Mansuet-Desprez, who actually cites Tifro in his footnotes alongside Dumas. Tifro, who must have been following the Academy's publications still, sent a letter to the Academy saying that he found Desprez unconvincing and that he still believed in his original ideas. But Dumas also critiqued Desprez in another paper the following year. Chevreul then chimed in to support Dumas. In other words, 2 of the people on the commission are chiming in to say, yeah, the metals probably maybe in fact be compound. And Chevreul promised a memoir reevaluating the possibility specifically of transmuting the metals. Perhaps something, I suspect, he began to draft as a member of the commission examining Tifro. Unfortunately, this paper of his never appeared. I hope perhaps I can find drafts of it. Thus, not only did Tifro's claims link up with debates then ongoing within chemistry, they also seem to have stirred up arguments within the Academy itself. So in 1858, what happened to Tifro? He retired to a private life, marrying, raising a family, building up a successful photography business. In fact, it's so successful that all you have to do is go on eBay and you can find photographs that he took. He must have made thousands of them. This is a picture of his shop on the back of one of his photographs that, yes, I got on eBay. I actually, last time I was in Paris, I went to see what was left of his shop, and it's actually kind of depressing. Let's put up the nicer picture. There we are. We can always have refuge in the 19th century. Only 25 years later, in 1884, did he reemerge to continue his work on transmutation. He wrote to Marcellin Berthelot, a chemist and now a government minister. He wrote to the French Commission of the Budget. He wrote to the Academy of Sciences. He wrote to the Society of Chemists. But this time, he received no responses. Now in the 1880s, the question of the elemental nature of the metals, although not definitively resolved, was no longer a matter of continuing debate. There's also some evidence, I think, of another thing that's happened in the intervening time, that is the closing off of professionalized scientific societies from the larger public. If you read the Academy's Compte Rendu from the 1850s, it's actually surprising how many little notes there are of the general public sending in observations or discoveries that then the Academy thinks worthy to put a line in their journal about. And by the end of the 19th century, that virtually entirely disappears, as if there's been a sort of closing off of these professionalized societies from everyone else. That would bear further examination. Perhaps also, another thing that had happened is that the occultist revival and reinterpretation of alchemy, which had spread to France from England in the 1860s, that is, after Tifro's first approaches to the Academy, now made the subject more distasteful, perhaps embarrassing, to scientists. because many occultists set themselves explicitly in opposition to chemistry and to the scientific establishment, saying that chemistry had become too mechanical and too lifeless, and declaring that alchemy and chemistry had nothing in common, a new divorce from the other side now, with alchemy as the superior discipline. So what did Tifro do? Again, he turned to the public. He began holding public lectures in 1887. He put his gold on exhibit at the Grande Exposition of 1889, the one, by the way, for which the Eiffel Tower was built. And he published pamphlet after pamphlet. Here's one of his photos. The out-of-focusness is my fault, not his. Unfortunately, even though he was behind the camera a lot, he never seems to have been in front of it, because the only image of him I can find is this that was published in a newspaper in the 1890s. And his pamphlets. Here are some of his pamphlets. Very, very rare now, very difficult to find. The popular press interviewed him sympathetically many times, while the scientific establishment remained silent. The most interesting turn came in 1891. Having read recent scientific papers on the discovery of nitrogen-fixing bacteria, Tifro concluded that the success of his process in Mexico depended upon the presence of unknown microbes that existed in the vicinity of gold deposits. In France, with no gold mines, those microbes were absent. Once again, a hopeful transmuter turns to the most recent scientific ideas. Tifro, in fact, hoped he could culture and identify these microbes, and what he did is he collected all the rain and gutter water he could in Paris, hoping that a few of the right mineral microbes might exist in it, carried through the atmosphere. And he slowly increased the acidity of the mixture to kill off the weaker microbes, hoping to isolate those able to survive in nitric acid and transmute the metals. Now, oddly enough, you might chortle at this, but oddly enough, Tifro was almost right. In fact, a little bit prophetic, because only in the 1980s was it discovered that a particular bacterium, Bacillus cereus, for some unknown reason, thrives specifically around gold veins. And in fact, biological soil assays can be used to detect new gold deposits, looking for this particular microbe. Very strange. All right. No sense that Bacillus cereus actually does transmutation, however. Yet. When the Academy refused to acknowledge a memoir he submitted in 1896, Tifro turned to a new journal entitled L'Hyperchimie, or the Hyperchemistry, published by the recently founded Société Alchimique de France, the creation of François Jolivet-Castelot. While Jolivet-Castelot came out of the new occultist interpretation of alchemy, he and other neo-alchemists were energized by fresh discoveries in chemistry. In particular, the discovery of X-rays, radioactivity, and radium in the late 1890s. Indeed, he envisioned what he called hyperchemistry as a fruitful union of 19th century occultist alchemy, traditional alchemy, and modern chemistry, a new field that he felt, and I quote him here, ought to replace our current chemistry. The chemists, for their part, were also about to embark on a new and more fervent courtship with alchemy. In 1901, next group of figures, in 1901, Frederick Soddy and Ernest Rutherford, both of whom would win Nobel Prizes in chemistry, discovered that the metal thorium decays into an inert gas that was later identified by Sir William Ramsay, another Nobelist, as helium. When Soddy realized what was happening, he exclaimed to his co-worker, "This is transmutation," causing Rutherford to snap back, and I quote, "Don't call it transmutation." I wish I could do a New Zealand accent, but I can't. "Don't call it transmutation. They'll have our heads off as alchemists." Well, despite Rutherford's worries, over the next 2 decades, chemists fully embraced the word transmutation and embarked on a frenzied search to make transmutation happen. From 1901 through the 1920s, many chemists, encouraged by the natural transmutation observed in nuclear decay, endeavored to cause artificial transmutations, and often claimed success in them, by exposing an array of elements to alpha particle emissions, to X-rays, cathode rays, ultraviolet radiation, and electrical discharges. Many chemists even began to embrace, again, historical alchemy, reclaiming it as a key, a crucial precursor to their own work. Soddy, in fact, declared that transmutation, and I quote him, has always been the real goal of the chemist, and that, quote again, transmutation is the final goal towards which chemistry should aspire. Others opined that radium was itself the philosopher's stone, and that early alchemists in the Middle Ages had actually isolated it centuries before the Curies did in 1898, a notion that was also expressed by some contemporaneous neo-alchemists. Ramsay, on the far right, worked perhaps most assiduously to effect transmutation and believed he had produced argon, lithium, and copper from other elements. And numerous reports of apparent elemental transmutations were published in Nature and the chemical journals. Now here what I find particularly interesting is that Jolivet Castelot and his colleagues labored simultaneously in their own labs on the same experiments, although more crudely performed, as the Nobelist chemists, saving up their money and buying these tiny quantities of radium to which they could expose different elements. In 1904, Ramsay even contacted and then collaborated secretly for 2 years with an alchemist in Philadelphia named Robert Melville Hunter, who claimed to be able to make gold from silver. And finally, in 1912, an alchemical society was formed in London specifically for the purpose of facilitating discussions between chemists, alchemists, occultists, and historians, which it did very successfully for 3 years until it had to close down at the start of World War I. Advertisements, interestingly enough, advertisements and respectful reports about this alchemical society appeared equally in Nature and in occultist journals at the same time. Some renowned chemists even started exploring other concepts from traditional alchemy, such as the notion that metals grow and mature in the earth. The new nuclear chemistry seemed to put everything up for grabs again. In fact, Soddy, here on the left, was sufficiently sure that the problem of gold making would be solved efficiently that he began to express concerns about the continuance of the gold standard, a point that Tifferot had already reached actually 60 years earlier in one of his little publications. As for Tifferot, he may or may not have witnessed anything of this. He disappeared after publishing a little pamphlet in 1906, and nobody knows what happened to him. Even his friends don't record in their journals that he just disappeared. I've searched the death records of Paris up to 1922, by which time he would have been 103, without finding him there at all. I would not take this as evidence that he discovered the elixir of life. However, I'm still working on that one. So it appears that the fates of alchemy and chemistry have been far more intertwined over the past 300 years than has generally been recognized, even recognized by me until recently. Far from suffering a definitive divorce in the early 18th century, chemistry and alchemy have repeatedly flirted with one another over the intervening years. Importantly, although some later alchemists continue to turn to the cryptic books of the earlier alchemists trying to interpret them, others turned as well, or instead, to the newest concepts and discoveries of chemistry in their pursuit of long-standing goals. Now, this dynamic, I think, sheds interesting light on the way science actually develops, not in our imaginations, but in historical reality. Neither by a linear movement from novelty to novelty, nor by an orderly accumulation of increasing knowledge, but rather by a really tortuous, unpredictable path full of turnings and doublebacks, where ideas and knowledge are acquired and then forgotten, rejected, revived, revised, only to be forgotten, and then revived and rejected again. Alchemical pursuits fell victim, as I tried to show at the beginning, to social, political, and institutional pressures, rather than to experimental or scientific refutation, while new observations and continuing human aspirations repeatedly revived them. In fact, I can tell you that from my own experience, there remain today, in fact, many people, many of them very serious and very intelligent, who are at work on alchemical transmutations, some of them even in our largest universities. I'm not talking about myself at the moment. And as always, some endeavor to interpret earlier texts, and others appeal to contemporary science for assistance and inspiration. So the story I've told you this evening could be carried down yet another 100 years to the present day. I felt uncomfortable doing the 19th and early 20th century as an early modernist. Late 20th century, just no. Maybe. At any rate, the successive making up and breaking up of alchemy and chemistry actually underscores the commonality of goals and practices expressed in the early modern period by the word chemistry. That's the one with two Y's in it. The desire to understand and to control matter and its transformation lies at the heart of both alchemy and chemistry, together or not, in chemistry, even during those periods when these goals were expressed or pursued in very different ways. It is, in the end, part of the long history of human desire to know and to do, and that, of course, is a history that's not finished. Thank you.
And we will have question and answer period now. Do you need help?
No, I guess, yeah. While you're formulating your questions, I'm going to get myself a drink of water. Yes.
Quick question.
Sir, we've got a microphone.
I totally heard about the use of linear accelerators to play around. Have you any information on that?
Well, that's right. The only time that it has been scientifically demonstrated to everyone's satisfaction that gold was made was in 1980 at the Linear Accelerator in Berkeley, when something like a billionth of a cent worth of gold was produced from bismuth by bombardment at a phenomenal cost, right?
Was part of the reason that the King of France, that he forbade them from going further, was part of it the same reason that Saudi had argued that it would flood potentially the market and destroy the value of gold?
Yeah, it's hard to say. I think, I'm going to answer that question in two ways. I think for Louis XIV, he was more concerned about his personal glory. That he didn't want people to think that, oh, well, you just have a bunch of alchemists laboring off in some dungeon somewhere making gold, and that's why you're so good. I think it was more about the king's person as the embodiment of France. And so I think that speaks for Louis. However, there had been before that a long history of legal actions against alchemists. The first one was Pope John the 22nd in 1317 wrote a bull, a decretal, not a bull, a decretal against alchemists, which began with the words, "The alchemists promise what they do not deliver and fall into the ditch." At any rate, what he was really worried about was, in fact, the debasement of the currency, that the alchemists would make something that looked so much like gold, it would get mixed in with the gold, and the value of gold would be, the value of the currency itself, the coined gold, would be debased. So the punishment, if you disobey the decretal, is that anyone who sells alchemical gold for real has to take the same quantity of real gold and bring it to the almshouse for distribution to the poor. I'll tell you one other little bit about this. There's an interesting saga that I haven't gotten to the bottom of, but it may have to do with what I've talked about here in this. In 1404, King Henry IV of England, also concerned about the value of the currency, forbade transmutation, although he allowed alchemists to buy licenses to practice it, which was a very interesting way of getting around it. 1404, this was forbidden. In 1698, that bill, that law against transmutation, was repealed due to the testimony of none other than Robert Boyle, who thought he was very close to solving it, and being a very upright and law-abiding man, wanted to make sure there wasn't a law against it before he went ahead and did it. The last part of the story is that for a reason that I still do not know, the repeal was repealed in 1940. So. Once the Roman economy started declining very rapidly in the middle of the end of the 2nd century, there were lots of ways of debasing the currency. At the beginning of the 3rd century, the silver coins had a silver content of about 80%. By the end, it was down to, or at the worst point, not quite the end, before Diocletian, it dropped to 3%. And they were giving them tin washes to make them look like silver. But this also has an alchemical connection. In fact, we have an account that the Emperor Diocletian ordered that all the books on chemia, which is the first time that word is ever used, the chemia of gold and silver, be burnt. Why? Well, Diocletian was, at that time, in the 390s, involved in reform of the currency. And in fact, there have been studies done of coins minted at about that time that their composition corresponds to the recipes given in some of the very few alchemical manuscripts of the time that survived their immolation. So, not to my knowledge. That's why I want to go to Paris and see if I can find it. I mean, I need to correct that. I'm sorry. Has it ever been analyzed in modern times? No. It was analyzed, however, several times during his own lifetime by the assay master at the Imperial Mint, who showed that it was almost pure gold with a small admixture of silver.
Sir, could you elaborate on Isaac Newton's contribution to this?
Right. This Isaac Newton's secret life as an alchemist is one of the best known secrets that there is, right? He's famous for his alchemical work. Known to have penned over 1 million words of alchemy, copied manuscripts, did experimentation extensively in his garden shed outside his lodgings at Cambridge. Newton was ordinarily a secretive man. With alchemy, he was even more secretive, so it is sometimes difficult to figure out what exactly he was doing. He does, however, seem to have been in communication with a few alchemists in England at the time, trading manuscripts, well, at least reviewing manuscripts of theirs, following out other kinds of processes. He even descended like a vulture on Robert Boyle's papers just a week after the poor man died, because Boyle had a process for transmutation that he refused to give Newton. And so Newton thought he could get it through the intermediary of their joint friend John Locke, who was Boyle's executor, and in fact he did. And actually the copy of that manuscript is now in Philadelphia. It turned up there very unexpectedly in my hands a few years ago, after having been lost at the infamous Sotheby auction of the 1930s, when Newton's papers were auctioned off to the general public. There's also a Newton manuscript here, a very important one of the few where he actually gives his own ideas about what's going on with alchemical processes.
Are you suggesting that actually gold can be produced, but it is not encouraged because it would debase the value of currency?
No, I'm not. No, I'm not. What my goal is to say that at many times in history, the idea of metallic transmutation seems eminently reasonable and undergirded by the most solid scientific evidence that we have. And at other times, it's laughed at. So there's this interesting swing back and forth of how we consider ideas of transmutation. Either it's the epitome of the foolish desires of avarice and greed and brainlessness that human beings involve themselves in, or it's at the forefront of our scientific research. Yeah, this is a difficult question. The general answer is that, well, I'll give you two answers. I always have to give two answers. It hedges my bets, right? Certainly, the oldest alchemical manuscripts that we know of date from the early Christian era in Hellenized Egypt. And there, most of them deal with trying to make imitations of gold, things that look like gold. At some point, the documentary evidence just isn't there because we don't have many manuscripts that survive. We have two manuscripts that survive from the first 10 centuries of alchemy. At some point, workers started thinking, well, if I can make something look like gold, that is, appear like gold to the eye, can I make it have all the properties of gold? And that starts around the 4th century. That's when that starts happening. Now, the other thing is that if you look at the metals, and you put them, imagine you have a whole bunch of substances in front of you. The metals all have things in common. They're all malleable, they're all shiny, they're all fusible, as if they're members of the same class, as if they're members of the same species. And if you examine, say, their melting points or their flammability, they have a sort of a range of properties. And I think that suggested to people that, well, they're so much alike, they must be made up of the same ingredients. Can I possibly take them apart and put them back together in a different way? I mean, the whole question of what is elemental, is there actually an unchanging element in the world? This is a question that goes back to really the earliest speculations that we know about of Greek antiquity, and it also promotes some of the most modern particle physics at the cutting edge. What is the unchanging basis of matter? That's a question we've always been asking, it seems.
I think you've already answered my question just in your, right here, just in your just what you just said there. I wanted two very elementary questions. The physical elemental characteristics of gold as opposed to the elemental or alchemic characteristics of gold. I mean, if you understand the difference. I'm trying to find out what is the difference between alchemy of gold as opposed to the element of gold, number one. And when was the connection of gold and sovereignty combined?
Gold and sovereignty goes way back. That goes into prehistory. There is something wonderful about gold. You can take a piece of gold and you put it in the ground and you let it sit there in the ground for 2,000 years and you take it out and it's just the same as when you put it in. It doesn't corrode, it doesn't tarnish, it's soft, it's beautiful. I mean, if you actually feel gold, maybe that's why I study it, but it has some character to it that you sort of want more of it, right? At least I do, I guess. In terms of your former question about the difference between, do you mean the difference between the way the alchemists saw gold or conceived of it as opposed to chemists? If that's what you mean, I would say that the way they conceived or perceived of gold or conceptualized it changed so rapidly that we can't make a clean distinction between the way alchemists and chemists looked at it over time in general.
You mentioned Newton, and I know after John Maynard Keynes bought all of Newton's papers, he said that it was rather disappointed by all the alchemy stuff. That maybe the fact that what you're presenting might somewhat rehabilitate, in the eyes of at least the English, we're talking about the continental approach, but I know the English were a little upset by it all and didn't want to talk about it. But was it just because he was so occult in his alchemy?
Well, the problem with Newton is that he was just so secretive about everything. So most of the manuscripts that Maynard Keynes bought were actually copies and transcripts of other manuscripts or printed books. It's very rare to find where Newton expresses himself freely about why he's doing that. And that's actually why it was disappointing, not that he was doing alchemy, but that he wasn't more forthcoming about that. But there's a large project now ongoing to try and tease out what Newton was actually about. So we may have some very interesting things to hear about soon.
Yeah, I was just thinking, I mean, this, from a philosophy of science point of view, it sounds like sort of like a metaphysical proposition of some sort. I mean, is this...
How do you mean?
Well, the point is in sort of testing it, or the conceptualization of this, quote, transmutation.
Mm-hmm.
I mean, it sort of sounds like metaphysics in a way.
I'm not sure what you mean by metaphysics there.
It's a proposition that's so high level that it's kind of, how do you operationalize it? How do you test it? Okay. Anybody written on anything about that? Alchemy from in other words, let's say like Popper, Karl Popper.
I thought you were referring to Popper. I mean, your question comes out of logical positivism, doesn't it? That's your use of the word metaphysical is actually the usage of the 1920s logical positivists, and not in fact the real definition of the word.
Right. Yeah, in a Popperian sense.
Yeah. Popper is not the only philosopher of science, nor is he the only one to determine. I am a historian, and so what I'm actually interested in is what people thought they were doing, or what they were actually, and what they saw and how they interpreted their results. So I actually don't see how it's metaphysical unless you're talking about the question of the ultimate search for the components of matter. What are they? And then in that case, then Thales and water and Aristotle and prime matter are all metaphysics too. So I don't really see that, honestly.
I think the gentleman tries to ask him about before the conquerors came to America, the indigenous people believed that the gold was something spiritual, it didn't have any value, economical value. I think it's very different. They believed that the gold was something to give you some type of spiritual power. Working is different.
Yeah, non-capitalist economy, so yes, that would make sense. No, seriously, right? Please.
Actually, what I'm thinking about, I'm an art historian of the early modern period, and all of the representations of alchemists in the 16th and the 17th century, by and large, are rather negative. As you may know, there are many, there is a preponderance of negative representation of alchemists in an alchemical studio. But wouldn't you say that despite the overlap between chemistry and alchemy and chemistry with the double Y as a sort of a common ground that they share, there is always a sense that there is a good alchemy and a bad alchemy. Alchemy that tries to deceive versus alchemy that really seeks the truth. And that precisely because you have this duality within the alchemical practice and discourse, you have these kinds of swings in terms of reception. And when somebody like Louis XIV is speaking against alchemists, he's perhaps speaking against those who pretend to create gold and create false impression as opposed to really fearing that somebody can come up with gold?
Yeah, I think there are two responses here. I think you're right, of course, that there's good practitioners and bad practitioners. And this is, of course, one of the things that the Dutch genre painters liked to tread upon, that the fault lies in us, not in what we're doing, but in the moral direction that we give to our processes. So certainly, the Dutch genre painters that follow upon the drawing by Pieter Bruegel in 1558, a famous drawing, for those of you who aren't familiar with it, famous drawing in 1558 of which he called Alchemist, which in Dutch is everything is lost. And it's a very negative image, and many painters thereafter copied from it or made references to it in a negative sense, of course. But there are also really some nice positive images. I think Teniers, who painted a self-portrait of himself as an alchemist, certainly is a more positive image, as are the paintings of Thomas Weick, I would argue. So I think there's a sort of versatility, maybe we can say, to alchemy that allows it to be directed to several different ways. I wouldn't count on that as an explanation of the historical swings of its popularity. I think I'd point more to the scientific currents of the day. But there's no question that when Bernard de Fontenelle, as the PR man for the Academy of Sciences, starts this rhetoric against transmutation, he's definitely drawing on popular imagery, both in art, in the theater, and in popular literature. So that certainly exists, and it plays a part into the story of how things disappear.
Dr. Principe, for the wonderful talk and the question and answer part of the evening. We can go on with this outside in the lobby of the museum, where we are having a small reception.